Hello and welcome to Perth South Model Railway. In this video I'll explain the powering of the reverse loops and I'll test them out. You'll recall from the plan of the layout that I have two reverse loops allowing trains in each direction to be turned ready for a return journey later in the operations sequence. Each reverse loop also forms a block with three sensors and is capable of holding the maximum length of train in the layout. A polarity changeover device is necessary when using reverse loops, and I have used a Digitrax PM42 unit. This is a very simplified view of a PM42. It has four sections, and each of these can be set up either as a short circuit manager or as an auto reverse circuit. Power comes from the low-level power district booster into two of the PM42 inputs. These two channels have been set up as short circuit managers for the down and up lines and their associated storage loops. The up or inner line output then feeds back into the remaining two PM42 channels, and these have been set up for auto-reversing. One for the north reverse loop and one for the south. Each of these then feeds through one zone of a BDL 168 unit. This again is a very simplified view of a BDL 168. Each zone can monitor 4 track sections, and 3 of these are used for each loop to provide power to the entry, braking and stop sections of the reverse loop block. This is the arrangement for the north reverse loop. Because this power circuit from the PM42 is specifically for the north reverse loop, the fourth BDL section is not used. To test the loops with automatic running, I need to set up suitable schedules in Train Controller. This is the dispatcher view used for planning and managing schedules. I have a schedule called Reverse North, which run trains from the hidden sidings to the north reverse loop and back to the hidden sidings. RS or Reverse South is a similar schedule and works the same way but for the south reverse loop. By linking these as successors to one another, the trains will run continuously from one loop to the other through the hidden sidings, with Train Controller deciding which of the available hidden sidings to use on each pass of the train. One thing I didn't mention in my last video was the connection between Train Controller on the computer and the Digitrax hardware. This is achieved by connecting a LocoNet cable from the Digitrax system to a device called LocoBuffer, which in turn is connected to the computer through a standard USB plug. Now let's run some trains and test the reverse loops. For the first test we'll use a Helgen Class 26 with Zemo decoder hauling a rake of maroon Mark I coaches. We'll then do a further test using 3 trains, letting Train Controller decide the best order and routing of the trains. Anyway, let's look at the first test runs. For the second series of tests, we'll use a Bachmann War Department Austerity with a rake of coal wagons, a Bachmann A2 with a fish train, and a Hornby B1 with Mark 1 coaches. great to see all this working, and already you can see the power of Train Controller. I think it would be almost impossible to run that sequence with 3 trains doing it manually. Anyway, thanks for watching, and if you like the video, please subscribe and click the little bell to receive notifications of future videos. Next time, I'll show the completed low-level system of tracks and carry out a full test using Train Controller with a test timetable set up to run 11 trains in 6 minutes. Will Train Controller be able to handle it? Watch out for the answer in a few weeks' time. Thanks for watching, and see you next time.